Good evening, everybody. I'm Kyle. This is Omotayo, and this is Ramin. Our subject is kind of recycling and how it ties into how technology can take recycling and turn it into a better, sustainable kind of source that we need to fix. Uh, like Wabi said, we come from all different nations, so I'm America. This is Iran, and this is Nigeria. And I'm going to give it over to Amatayo to take it from here.
Hi, class. So tonight we'll be talking about recycling, and now we can make it work with a 3D printer. So first of all, I would like to discuss about. Before I go further, these are the list of what I will take during my session. I would like to discuss about what exactly recycling means, the history of recycling, the steps to take to make recycling happen, and then, of course, waste. So, what is recycling like? I would like to involve the class. Anyone with, I know we all know what recycling means, but anyone with a brief definition what recycling actually means? Anybody, be free. Anyone? Do you want me to pick names?
Speak.
Just speak.
Speak up.
What is recycling?
Collecting the waste to utilize it for something,
Mm-hmm.
generating electricity or soil.
Exactly. Take something and rebuild it. You know. What?
Reusing the waste material.
Exactly. Reuse. Take it from something you don't want anymore and make it useful once again. So basically, recycling is like you can take over your dump, like waste management, whatever you think you don't really need anymore, and manufacturing it into something new. All right, let's go. So the history of recycle. All right. Um, it was said that recycling has been going on since the beginning of time. Like the ancient time, the Romans, they actually turned their bronze coins, they turned it into statues. So at that era, when they think they don't need to spend the bronze coins anymore, instead of just dumping it somewhere or dropping it in ocean, they turn it into statue. And history has it to like places where there were difficulties in having food and famine or whatever, they actually result into recycling more often than places where they have abundance. So this has been going on since the early days. And so this brings us to the question, why do we recycle? I mean, especially in this current world where resources are kind of abundance and we have machines and equipment to reach the resources and as much as we like. But why do we still need to recycle? Anyone with an idea?
It's gonna save the new sources for it.
Huh?
It's gonna save the new sources which we are gonna use.
Exactly, sustainability.
Yeah.
Yes, we need to make sure we don't deplenish whatever we have. Yeah, that is true. So we recycle for so many reasons. Sometimes because we want to keep the earth safe, we don't want to finish up everything we have now and leave nothing for the rest that are coming after us. And sometimes for cost reasons, like you know, if you take whatever material you have and turn it into a new one, you don't have to go to the extent of buying a whole new thing. Like, you can have a plastic bag you got from Walmart and use it into something else. You are recycling. You don't have to go through a machine or whatever. You know. So the steps you need to take in recycling, first of all, you need to gather whatever you need to recycle. Then the next thing you need to process it. That's when you sort maybe contaminated ones from uncontaminated ones. Then the next thing you manufacture, then you put it into market. And that's where we have these men like trying to sell it in market, and then it goes again. Because once it gets to the market, it's still gonna be purchased and become a waste. So let's talk about waste. You cannot recycle if you don't have a waste. I mean, who would recycle a new thing? It doesn't really make any sense. So waste is essential in part of recycling activity. And then we have something called pollution prevention, and that's where the 3D technology actually plays a major role. Because pollution prevention, tells you to stop pollution from the top. Like, you know, usually when you want to pollute, you dump refugees, right? Once you're done with the material, you try to trash it. But why would you trash it? Why don't you take it through a process and bring something new? And that's where you have your 3D machines, 3D printers, you know. You generate objects, whatever you want to generate from probably a waste. Like the previous group tried to show us about the skin printing out. That's a 3D technology, you know. You take something, build it, and get something new. And I would like to hand over to him so he can tell you more about waste and the PET and whatever. Thank you.
Hello, everyone. I'm going to talk about PET, which is the common municipal waste in our country. And I'm going to talk about what is PET, what are the characteristics of PET, what are the applications of PET, and why should we recycle PET waste, actually. So PET is the most common thermoplastic polymer resin, which is categorized as the polyester family. In the picture on the left side, you can see the monomer of PET, which is the chemical formula of PET is like C10, H8, and O4. And in the picture on the right side, you can see the polymer of the PET, which consists of the monomer in a chain pattern, actually. So these are the characteristics of PET. Basically, we can have two types of properties of PET: physical and chemical properties and industrial characteristics. So for physical and chemical properties, we have density, which is 1.4 gram per cubic centimeters, and comparison to water, it is like 1. Melting point, it is 250 Celsius, 0 for water. Boiling point, 350 Celsius, 100 Celsius for water. And specific heat capacity, which is 1 joule per gram Celsius, and we have 4.18 for water. And we have industrial characteristics of PET, which are low weight, high safety, high resistance, high transparency, and high changeability. And regardless of all these characteristics that I talked about, the golden property of PET is like it is 100% recyclable. It means that you can use a piece of PET, recycle it, and reuse it again, and again. So these are the applications, the common applications of PET. PET granules, which are basically feedstock for industrial application. Drinking bottles, which is the most common application that most of us deal with like every single day in our life. Assorted containers, wall insulation, microwavable trays, food containers, synthetic clothes, and synthetic carpets. So like I said, the drinking bottles is the most common application that I'm going to talk about later. So why should we recycle PET waste? Basically, considering PET bottle and as the index, like I said, in this picture you can see that the price of making a plastic bottle is compared among these countries, including Japan, European Union, China, United States, and Middle East. So there are some factors that affect the price of making a plastic bottle. Naphtha and ethane as the raw materials and related costs, electricity and fuel as energy and related costs, labor costs, and other costs like transportation, if you will. So as you can see in this picture, naphtha and fuel, they have the significant share of price in making a plastic bottle. So that's the reason that we should recycle PET waste to reduce the naphtha consumption and related costs and fuel consumption and related costs. And notice that countries who import crude oil, they should take care of the recycling like more than the other countries. And that's the reason that like Japan or industrial or Scandinavian countries in European Union, they have been trying to establish a green culture in municipal communities to increase and to motivate the communities to participate in recycling PET waste. So 3D printing is one of the technologies that can help us to recycle PET and basically to localize the recycling. So the idea is to turn the PET waste to plastic cartridge and make a new product from small scale or large scale 3D printing. So Karel will talk about the printing and the technology.
Thank you, Ramin. The whole purpose for us today is to introduce technology that is starting to take this waste and actually turn it into something else, like household items or new types of personal equipment for either the individual or the business or even the corporation. Because with an abundance of waste, we're trying to reduce it all and to reuse it for some other purpose. And there is a company called Cubify that has designed and implemented a cube that uses cartridges that are from consumer waste products. So just like Coca-Cola bottles down to this type of plastic right here, you're able to reuse and then repurpose the waste instead of just throwing it away in a landfill. This type of cube exclusively prints from post-consumer waste. It recycles what is used, and the individual can remake 3D prints into personal items, like a cell phone carrier or a case, or down to anything that you want designed in your own home. So it's very user-friendly when it comes to the individuals that live on their own or are design engineers or even just people that do regular things. The cartridges turn the equivalent of 3 bottles into your next design. So 3 regular 12-ounce Coca-Cola bottles can get you a printable phone case or whatever equipment that you want. It uses a plastic jet printing, which yields strong material with flexibility. So, like I said before, if you wanted a brand new phone case or a new type of device around your house that can, like a bookshelf or like a book space divider or a bookmark or anything that you want, you can come up with it, you can design it, and you can implement it into your life. The specifications of this cube, it's pretty simple. It's 13 by 13 by 9. So you can imagine that this thing is about this big. Lightweight, only 17 pounds. I'm sure everybody in here can lift that. If you can't, hit the gym. The work envelope is a lot bigger, so even though the cube is relatively small in size, you can produce products that are bigger than the size of the cube. It connects to Wi-Fi, and it's also interfaced with either an Android or an iOS app. So say you're on your phone and you're like, oh man, I want a new phone case, or I gotta create this. You can design it on your phone, send it to the printer, and it could print it out right there within 10 minutes. The maximum design size is 6 by 6 by 6 inches. So that's full scale, high density. You can design something within that cube. And that's it for the technology that we introduced that uses consumer waste. Are there any questions?
Yes. Here's a question. How would you fill the cartridge of that cube with the Coke bottles?
The cartridges are sent from the company, so.
How do you
Put it on?
do you crush the bottles? Do you crush bottles?
No, the actual process of
Mhm.
reducing the waste is through the company.
Sorry.
They would send you the cartridges.
Yeah, but you should crush the bottles or should melt the bottles to fill the cartridge, right?
Not at home, no.
Not at home, but if you melt, I mean,
Well, yeah, if you
you are recycling, right?
Yeah.
So once you melt the bottles, it will be more.
More fit, yeah.
Yes,
The density would raise and you'd get a lot more.
and more polluted.
No.
Yes.
Because we're repurposing it.
No, if you melt a plastic, okay, what does PET stand for?
What?
PET stands for,
Polyethylene terephthalate.
yes, polyethylene. So it's a plastic, right?
It is a plastic, but it's the most recycled and repurposed plastic.
Okay,
That's why it is used.
normally you can recycle it, but how would you fill the cartridge there?
At home?
Not at home. Generally, maybe at a company, maybe at a company or anywhere.
It would be crushed, cut down.
Would you summarize everything because it didn't go to the?
Yeah.
I mean, I really don't know the process of how they reuse the plastic, but usually it gets cut. It gets cut down. It gets brought down to a smaller scale and then regrinded and reused.
Into tiny mixture. Just a second, get the microphone. Why don't you get next to each other so you use the same microphone? Now, what PET stands for?
PET stands for polyethylene terephthalate,
Okay.
and dependent on the process that it's used to be broken down. So either extruding or injection molding.
Molding? Injection molding?
Injection molding or extruding. The regrind,
Injection molding, I think you should have in a paste form, right?
the base form is PET.
In a paste type material, you should have for injection molding, right?
Yeah, but in order to mold something, you'd have to heat it up.
Yes, but you can't mold it, right?
Yeah, you can mold it into whatever you want.
But you can't heat it.
It's heated in order to produce a plastic.
But once you heat plastic, it gives more pollution.
You mean by emission?
No, yes, maybe in many process, yeah. Generally, when you heat plastic, you'll get more pollution out of it.
Well, out of emissions,
Yes.
but not by actual.
Not by contaminated.
Yeah, not by landfills or
Okay, how much
general
time does
mass.
it take for a PET to decompose?
Hold on, let me get it right. Is the question about the pollution coming out of the plastic melting
Yes.
or the molding of the plastic?
Both.
Okay.
Our purpose is to reuse instead of generating PET to be out in the land. Like any process that's going to happen, even oil or anything, that generates emission.
It's a physical process. It's not gonna release
So
any gas.
the emission, the gas coming out of it, we didn't cover it here because we're just talking about the recycling process.
Yes.
So when it comes to the waste coming out of it in form of gas, that's another thing. You can pass the gas to whatever you want. Like, you can have a pipe connected to wherever you wherever you melt it, and then you pass the gas to whatever you want to do. Like, you can pass it to some kind of water surface, to get your reaction, whatever you want. But that wasn't covered. What we're trying to tell you is you take your plastic, you melt it down, you put it in your ink, depending on the style you want to use, as you said, and you get it programmed according to what you want to mold.
Okay, in the cartridge in the form of a powder or
It's a cartridge, so it's a long string of plastic.
from that you'll mold it.
Yeah.
Yeah, it's molded into a long string of plastic.
That's what.
Clear? Any more questions? Satisfied?
I think preventing the usage of plastic would be much more easier
That's good.
You have a question?
than all of these.
You have a question?
I mean, not
No,
a question.
that's-
Just want to extend this discussion.
Okay.
I thought reducing the usage of plastic would be much more
Sit
easier
here.
than.
So we have it on the camera.
I think reducing the usage of plastic would be much more useful than recycling it and producing. I think even recycling produces a little bit of air pollution. So
Okay. Very good. Any other questions?
He wants to elaborate on what he just said.
Yeah, well, I think, yes, you can reduce how much plastic you use. But think of the beauty, like, you have this kind of plastic, and then you form these out of it, You had this kind of plastic, and then you form these. Like, you had these, and then you made these out of it. That's beautiful, right? Just in your home.
To elaborate on on your thought, this process is actually reducing the plastic that's being made because we're repurposing it. Well, you're saying just reducing it in general and not repurposing it. Yeah. Well, what we're trying to say.
Once we reduce the usage of plastic, all these issues would be taken away.
Yeah, I mean you're right, but the thing is that if we're not repurposing it already, then there is no reduction. Like we're just going to keep using it and using it. Now, instead of those 3 bottles going into a landfill and going into the ocean or going into the ground, they're going to be repurposed and created into something that we could use every day. That's the point of the discussion.
I guess every plastic is not reproducible. There is a case with PepsiCo. They stated that their PET bottles can be reproduced, and there's a case in the US.
Sorry, would you come and he wasn't just your voice? It will be on the tape, nobody will hear it. So come here, please. Come here, please. Come on in. That's exactly the spirit of this class. Come on in here. So exchange the microphone so the voice would be easier, please.
There is a case with PepsiCo. They said that their bottles can be recycled, and there's a public interest litigation posted at the law of court, and it proved to be wrong. Not every plastic can be recycled, and for example, if you take your mobile phones and your mobile phones are also made with some sort of plastic, and even they cannot be recycled. They are directly dumped into the earth.
Polyethylene terephthalate is the most easily recycled.
I remember I said you collect. Remember I said earlier that part of the process of recycling is collection, sorting. So you have to sort. Like you have all this bunch of plastics, you need to sort out those that you can recycle. So that would have been taken care of at the processing stage of recycling. Cool?
Very good. That's really the spirit of this class. And look at the video after Cats would edit it. It will be very lively discussion. They will cut out the things that you don't want to see, and they make it really exciting with music and everything. Very good. Any other comments? Any questions? Yes. You have something? Oh, okay. Very good. Very good. So, are we ready for the last but not least? The last but not least. Yes.
That is needed.
Okay. Let us give them a hand, please.